I will continue with a new matter that actually conditional operations. Conditional operations, folks. Computer not only make calculations or doing textual work, computer also able to make decision. And to make decision, computer must use so-called logical operations. Logical operations or logical algebra or algebra of logic, it's very ancient topic and was developed by ancient Greek philosopher by Aristotle. Aristotle actually selected three different logical operations. One operation named conjunction. Conjunction. Let me explain what conjunction is. Consider that you have two events or two logical cause, let's say that. One of them is you desperately need a car. So I will name it event A. Need a car. And then event B, you do have a money. And event C will be go to the store or dealership and get a car. But in this algebra of this logic, true is equal 1 and false is equal 0. As we're told, folks, binary arithmetics and binary digits are very useful for many things that have relationship with two sides. Let's say left and right, up and down, black and white, and so on. So true and false is one of them. And to set up the logical function, which is conjunction, I need to make a table of conjunction. Table of conjunction will have 3 columns and number of rows. I'll go for A, B, and C. If you remember, A is when I need a car, B is having money, and C is getting a car. If I say here 0, so I don't need a car, neither I have money, so I don't know what situation in my life could be like that. I cannot drive and I don't have money, so that's definitely I will not get a car. If I go and desperately need a car, but my account is zeroed, so in this case, folks, nobody give me a car. So I will go for 0 as a result. Then, I don't need a car, but I have tons of money. Consider that I have helicopter or the aircraft, and in this case, I will not go to get the car. And only if I get desire and get money, I will have a car. So, folks, the function is AND. When A is true and B is true, then C is true. Only when they are truthful, both of them. This function is a part of algebra, folks, and let me go and write it down in the logical form. A and operation and or conjunction looks like a little birdie wings down. So A and B, both truth, then C is true. So this function, folks, defined by the table, and this table named table of truth. Next operation, folks, next operation named disjunction. Disjunction. Disjunction, guys, is also have two variables or two components, which actually A and B, and the result is C. Basically, they can have more than A and B, A, B, C, D, and result will be separate from them. Now, let me describe the situation. But describe the situation, I will go for the table first, and because the function of disjunction is actually setting up with a table of truth. Consider A when I can go to one doctor, B when I can go to second doctor. Both doctors are supporting my insurance and can give me prescription. So C is getting drugs from the pharmacy. A, B, C. So consider that I neither go to Dr. A nor to Dr. B, and definitely in this case I don't have prescription, and my truthful about C, getting drugs, will be false. False meaning zero, nothing. Then I came to Dr. A, I didn't go to Dr. B. Dr. A gave me a prescription, I got drugs. I didn't come to Dr. A, but visited to Dr. B. Dr. B will give me prescription, and I will get drugs. I can go both to one and another one. And in this case, either one give me prescription, so I will get drugs. The situation here is different, logically. When I have at least one operand, either A or B, truthful, then entire function is truthful. So this is disjunction. How the formula looks like: A or B, either one of them is true, then the result is true. You see the functional symbol of disjunction is birdie wings up. Folks, the last function in algebra of logic that I would like to introduce to you is negation. Negation. Negation is negation. Negation is negative. Negative meaning somebody said truth, then that will be false. Somebody say false, negation will give you true. The table of truth is very short, so we'll go for only one operand and one result. So A and B. If A is 1, B is 0. If A is 0, B is 1. The formula for this negation looks like this: A is equal no B. So no truth is false. No false is true. Third is not possible. So this is three logical operations, folks. Three logical operations that give computer opportunity to make a decision. How computer make decision, folks? For example, to get your EasyPass tag, you need to be responsive to the certain events. A, you need to have a car. B, you need to have credit history. C, You need to have permanent address. D, you must be resident. And E, you must not have a criminal record. All of this data could be true or false. Then equation will be looks like this. T as tag will look like A and B and C and D and no E. So take a look. E is a criminal record. No E is no criminal record. So criminal record must be 0. No 0 will be 1. So 1, D residential, 1, C is permanent address, B is good credit story and good history, and A is a car. All of them together will give you tag equal true. That's how it works in a computer. So computer analyze a lot of events and need to know they are true or false. So folks, for analysis of this true or false formula, computer must have so-called programs. By the way, computer is programmable device. Programmable. Programmable. What is programmable, folks? Computer actually doesn't know what to do. Computer doesn't have brain. Computer actually work under the control of the commands. And program is a sequence of commands, of instructions. Sequence of instructions. Every instruction actually controls the microprocessor or processor of this computer, so computer actually knows what to do from this program. Who create, or can computer program itself? It can, but it's a different story. But so far we will go for something that defines a profession named programmer. Programmer is a person who knows programming languages and use them to program computer. Before program is actually written by programmist or programmer need to imagine the sequence of operations and all conditions that he must remember in graphical format. So graphic format of behavior for the computer named algorithm. So it's explicit description of the behavior. Explicit description for the behavior. What computer and how computer must do something in a matter of make decision or calculate or do whatever. I would like to make algorithm for human to give you samples, a pretty simple sample of how to describe the behavior. Consider that some individual or you in a square room with one door outside, and that is you. How to find the door? Algorithm will look like this. Start. Start is always function to run this program. Start. First option will be watch the wall. That is unconditional operation. Watch the wall. Then conditional logical operation will analyze this wall. Is the door here? And this is a question. Is the door here on this wall you watched? Could be two answers. Yes and no. If yes, definitely you need to open the door, and next operation will be go out of the room, and that will be exit from the program. Now, what's happened with no? If no, I need to turn 90 degrees. So let me make this operation. Turn where? Left. Let's go to the left. Turn left 90 degrees. And then I need to go to watch the wall again. When I watch the wall, and the question will be, is the door here? If yes, I must go open the door and go out and then exit. If the door is not here, take a look, folks. This is not the door. This is not the door. This is not the door. So the person must turn to the left 3 times if he or she is in the position where he is not in front of the door. So turn left and then check. Watch the wall, and is the door here? So folks, is the door here is a logical conditional operation, meaning this operation have the answer yes or no. Overall system named algorithm, and computer actually realized this algorithm as a system of operations. One by one, all of these operations are located in the computer memory, and processor taking this operation one by one, first, second, third, fourth. But when computer find the operation conditional, it could be jump to another location of the program, like here. So everything going in sequence. If yes, if no, that will be turn and the jump. So that is jump operation. So folks, actually that will be assignment to write down the algorithm for any activity that you choose yourself. And we will speak about algorithm and program a little bit more in the next session. So far allows me to stop my recording, and I will supply you with this overall explanation. Thank you.